Lighten it up in part 2. So we're ready to fire this up. What I have going on is just a set switch to cycle the fast set time. Make sure digits are working. Resistance substitution box over here. And we have to figure out this value for the reference resistor. Alright. We already did this one, the filament string. We already checked that. We just have to figure out what resistance we're going to use here. And that's going to be a visual check with the intensity on the display. Should the display light up properly? And we're about to find that out. So as they say, fire on the wire. I'm not seeing anything, and we got nothing. Well, we're going to have to do some checking. I obviously forgot something. Sometimes this happens. Okay, I did a quick voltage check. Let's fire this back up and see what's going on here. Oh, okay, this is gonna go on. Oh, we got something. That's why I didn't light. Something over here on this test hook. Alright. But it's madly counting away. What's going on? Oh, this setting button. Ah, it's a normally closed button. That's one thing. We have seconds counting as long as I hold the button. Yeah, so that was the fast set being engaged because I selected a button out of my scrap bin, and it is backwards from the way I want it. Should be a normally open button, but it's not. We have seconds. We're missing 2 digits. Something's going on over here. We're going to have to investigate this. Now, I use a junk chip when I fire these up, so there could be an issues with that IC. Although it is tested, but maybe I have solder bridges. I'm going to have to do a little bit closer inspection. But we have something, and it works somewhat. One of the voltages that should be up toward 40 volts, we're running a little low. Maybe it'll work. Let me sort out some of these other issues. There could be something pulling it down a little bit, but yeah, this is where we're at. They don't always start up perfect. I kind of rushed through this one, trying to get it lit up. We get some weird ghosting and stuff. These aren't doing anything. We're going to have to check. We might need to get the scope out. Alright. We still have this one out and this one out. This one's now lit. What I did do was screw up 2 connections. I had to switch these 2 because I had them reversed. So there was an error there. I'm going to probe the outputs of the IC here, and it's going to be the 6-digit driver outputs, and you can see the difference. We're having trouble with this one and this one, the tens of hours and the tens of minutes. So let's see, pin 1, 2, 3, 4, 5, 4, 5. Okay, that's a typical output. The low part is active, the high part is off. Same for that one. Look at that one. Next one. Good. Next one. Again. So we have two outputs that are wonky. I disconnected the display board just to rule that out, and the outputs are still not right. Okay, looking at the two transistors that are in that circuit, the digit driving circuit, the two affected, you start double checking the work. Now, let's see if I can find it in the camera here. It's hard enough to find it beforehand. Oh yeah, there she is. See right there? The end of the wire, when I soldered it on, the end of the wire is poking past the pad, touching the next pad over. And I confirmed it with a continuity check. It's supposed to be not connected there. So we're going to just heat that wire up, pull that back a little bit, and see if that fixes the problem. Alright, here we go. Ooh, we have old digits. Alright, we just got some funny flickering going on over here. Other than that, this thing is working. Now, it's not the brightest clock in the world, but I think one of my supplies is a little lower than it needs to be. The 36 to 40 volt supply is actually measuring in at 29 volts. So I may experiment with just subbing in another supply to see if that affects the brightness and to see how it behaves. It does have some ghosting issues. Just on the end tubes. It could be the IC. I may try to put a more current IC in there. That's a 1973 one, I think. Sometimes the later ICs are a little better with between digit blanking. Okay, now we have it fired up. I cut the 35 volt supply out. which was only producing 29 volts, and I supplemented in a separate power supply from over there, two separate 20 volt outputs series together, monitored by a Nixie voltmeter underneath, and right now it's currently at 29 volts, and I'm going to drive it up slowly and see what the display does. "32 volts, 34 volts, 35 volts, 38 volts, 40 volts on it. It does look quite a bit brighter. Bring it back down to 35 and play with the resistance substitution box here on a filament reference. You go too low and you start getting this. Bring that back up and resistance, that goes away. That's interesting. So yeah, I had that down to 680. Even 1,000 is too low. 1,500, 2,200, about the same intensity. We'll probably leave that reference resistor somewhere around 1,500 to 2,200, which is pretty much what the schematic calls for. Okay, this is where the one supply was running. Now we're supplementing that one supply. So the 40 volt rail needs to be at 40 volts, as in the original schematic. Pretty crucial to get brightness out of it. We're going to have to do better with our one supply. So we're looking pretty good. Just a little tweaking, measuring, playing. We don't have really much ghosting at all on the end tubes anymore. The reference resistor actually played along in that a little bit. Unfortunately, this power supply droops down when you load it. And there's not much of a load on it, but that supply unloaded and measured 36 volts. Running, it dropped down to 29 volts. So we're going to have to do a little bit better at that. We got to get that 29 up to 36. So that's the next thing. We got to play around with this 36 volts here. We need at least that up to 40, and it'll be a happy clock. So right now it's currently running on accessory power supply to get that 40 volts. Dialing it down back to 36. The intensity doesn't change too much. Down at 29 volts. Not quite bright enough. So transformer, power supply, that's next. The schematic calls for a 30 volt AC winding. I used a 24 volt one. I had that on hand. I'll swap that with a newly obtained 30 volt transformer, which would have a center tap to still be able to run the low voltage supply as well. She's much happier. Took this transformer out. This was the 24 volt transformer. Here we have the 30 volt transformer. Our supplies are looking better. So we're shooting for 36 bare minimum. This transformer doesn't have as much sag as the last one. So we ended up at 43 volts. And on the other rail, 15.7. You can see with the power supply upgrade that the display looks much brighter. A viewer, Enigma 758, has turned me on to a document on VFDs. Carries a lot of useful information. I will link that below. So reference this document, the one section talks about a reference resistor and different ways to connect that. If you remember from the first video, I had shown you tying in a reference from the filament string to ground through a resistor. It was done here. I also showed how changing that resistor affected the display. In that document it talks about use of a center tap transformer for the filaments and actually using a reference off the center tap point to help with illumination of the various digits in a more uniform manner. The way I originally had this wired with the reference resistor here as opposed to center tap actually worked out pretty good. The display was aesthetically pleasing and uniform, partially probably due to the fact that I could actually access the center of the filament string for this connection node, which I just noticed I had represented incorrectly here. This is actually the way I built it, connected up in the middle of the string. Maybe possibly in a modular type envelope sealed VFD with multiple digits, you may see a thing called luminescent slant, where one side of the VFD may appear brighter than the other side, where you can't access the center of the string or you're not using a center tap transformer. Not the case here, but since we had this center tap available, why not? I have eliminated this resistor and moved it to the center tap transformer, which is actually in this design, which I wasn't going to use at first, but since it was there, I thought it to be a better way to go. Changing that reference resistor like we did before, we're just going to knock it down a couple, and you can see you're starting to get weird flickering here. And what you're doing is you're moving a bias between the filament and the anodes and grids close to the ground, and you start getting these weird flickers and ghosting. We'll take a look at the scope while we're at it. Okay, so we're going to have the scope on the center tap. You can see the potential. We're on 5 volts per division, so we're above 5 volts, below 10 volts, say 6 or 7 volts, and you can see the AC and DC mix there is the way I take it. And also, just turning up the intensity, you can see a half wave form right on the ground line, which is interesting. Now watching it, while I adjust the reference resistor closer to ground, I currently have a 22 ohm resistance between ground and the center tap of the transformer for reference. Okay, it's 1500, and about 1500 now I'm starting to see ghosting on the seconds just a little bit. We go down to 1000 ohms and we got some pretty significant flickering on the seconds digits on the unused segments as we approach our reference closer to ground. Bringing that back up calms the display down. You can see how we can also use the reference resistor to adjust the brightness. We're going to move it up to 10,000 ohms, and you can see that's a good nighttime mode. Back to 2200. Good daytime mode. One thing to note with these tubes in the bright light is brightly lit as they are displaying, which shows up on camera quite well. To the eye, the contrast is not as good. The unlit segments are white in color and the lit segments light up. Some would say there's not enough contrast there, so where filters come in, something such as this, a piece of tint, actually helps quite a bit. I may end up putting tint on these tubes. This is just window tint from an automobile. Not sure if I'm going to go with a colored tint like a blue. If somebody has a little experience with this, maybe leave a comment in the comments section. The finished product of this clock was intended to go in a wooden cheese box. I may end up making a clear acrylic enclosure for this. Just a show the works design. Let me know your thoughts on that too. The enclosure of a homemade clock is always a whole nother level of a project, so we probably won't get into that into this video, as this one's approaching a long length as well as the first part. If you haven't seen the first part, do check that out. So now this clock is looking pretty good, looking and working pretty good. I might consider some sort of call-ins. First thing that comes to mind is a smaller VFD tube, maybe lighting the top and bottom segments for dashes. If we can position these just right in there, that would look pretty good. I kind of like the look of round call-ins. You could do that with LEDs, but the colors, you can't just get the color to match. Green LEDs won't cut it, but I think going for some smaller VFDs, these are the IV-3As, that might be the ticket. Any of those additions will be in the next video. We're going to wrap this one up here as we're again approaching 25 minutes. This is slightly different format than I usually do. Longer videos, a little more techy, maybe. Although I'm not super techy, I'm a novice like many of you watching. Maybe let me know what you think, how I'm doing. We're all learning here. The simple clock building hobby has definitely been a learning experience. Pulse shaping, transistors, power supplies, all and the like. Learned a lot. Thanks for watching.